All right, so let's kind of continue. That's why I put B, 3.5b, with what we were doing yesterday. So let's do a quick review, and let's get kind of practical here on what we were doing yesterday. All right, let me change this so I can write on here. There we go. All right, so what if I asked you to graph an equation of a line? All right, so my writing is so bad on this new tablet. I got to figure out what I'm doing wrong. All right, I'm just making this up off the top of my head. Okay, y equals, I don't want real big numbers. Let's say 4/3 x minus 2. All right, I don't know. Maybe we did that yesterday. Maybe we didn't. I can't remember. So let's grab this graph right here just to make it kind of accurate. Let's expand it just a little bit. All right. First of all, let me ask you a question, because we're going to talk about another form of an equation of a line today. What is this form called? This, I'll give you a hint. This is y equals what? mx plus b, right? There's a name for that. What's the name for that form right there? Slope-intercept, right? They don't put the word y in there, the letter y in there, but it is the y-intercept. But they call it the slope, I'll just shorten intercept form, okay? We're going to do another form today, but this is the one that we use quite a bit, all right? I'd probably say we use this more than any other form to graph a straight line, okay? Very important, okay? You learned it in Algebra 1, probably. You're learning it in geometry. You'll definitely 100% do it in Algebra 2 next year. And if you continue on with your math, you'll be doing it then too, all right? It's very, very popular. Anybody that's taken any math knows y equals mx plus b, and they know slope-intercept form. All right, so what does this stuff mean? So looking at this thing right here, there's two things that I'm really interested in. What's the first thing I'm interested in here? I am interested in the rise over the run, but the first thing I'm going to put on the graph is not the rise over the run. What's the first thing I'm going to put? The -2, which is the what? Yeah, it's a point, but specifically the y-intercept, correct? So I'll just put that right there. That's the y-intercept. What does that mean when I say the y-intercept? What does it mean? Well, you got a y-axis, don't you? So what does it mean? What do I do? What do I do to this graph when I see that -2 on the end like that? Go to -2 on which axis? The y-axis, right, the up and down. So I go right on here to -2, and I put a point right here at -2. Can everybody do that? Yes? All right. It's not that hard, right? You look at the number on the end. If it's plus or minus, right? What if it was +2? You go to +2, right? Okay. And you always put it on the what axis? The y-axis, because it's the what? The y-intercept. It's where it crosses the y-axis. I think I've made that pretty clear, right? Okay, good. Now, that was the easy part. The next part's not much harder, but it's like 2 little steps you got to do, okay, which is this right here. What is that thing? Okay, but don't say rise over run. What is it? Give me one word. It's the slope. It's the slope, okay? Now, the slope is the rise over the run. That's true, okay? But this number right here, it could be a whole number too. Okay, we haven't done that. I don't think we did that yesterday. I think we'll do another one just to show you. So anyway, that's our slope. Now, you guys already said it. You love saying it. What? Rise over run, okay? So where do you start now? You go back to the graph. Put your pencil where? All right, on the y-intercept, right? At the -2. Don't start here. Everybody hear me? All right, start at the y-intercept. And then what are we going to do? We're going to rise what? 4. 1, 2, 3, 4. Don't put a dot just yet. Just keep your pencil there. And then do what? Go to the right 3. That's a run +3. 1, 2, 3. Put a point right there at that dot, or at that point right there, that spot. And then that's really all you need, just 2 points, and you can make a straight line out of it, right? What did I suggest that you do if you're going to graph it? Yeah, you can go the opposite way, or you can just do this a couple, just to kind of spread it out a little bit so you know you're pretty accurate with your ruler, okay, when you actually do it. So let's do it one more time. Right here, let's rise 4. 1, 2, 3, 4. Let's run 3. 1, 2, 3. Plus, it also makes sure it lines up. You see that? I could go the opposite way. I could go what? Down 4. 1, 2, 3, 4. And to the left 3. 1, 2, 3. Does it line up? Yeah, everything lines up. It's really nice. I just kind of like to stretch the points out a little bit. It makes my graph just a little bit more accurate. And there you go. And that's all there is to it. So if I asked you to graph something, that's what you would do. It's one way to do it. That's one way. There's another way to do it as well. All right? Everybody see that? Let's do one more just for fun, okay? You don't think it's fun? Yeah, it's fun. All right, let's do another one. What if I said y equals 3x plus 1? We'll do this in a different color so it doesn't get mixed up with that one. All right, so what's the first thing you're going to do? If I ask you to graph this, and this will definitely be on a quiz or a test, or a quiz and test, okay? I'm going to ask you to graph several different things, and you need to be able to graph it. Abdul? Okay, good. Go to the y-intercept, okay, on the y-axis, go to positive 1 on the y-axis. Very good. So that's our first thing that we do. Now, look at the slope. The slope looks a little different than this because I can see the rise on this one right here. What's the rise? 4. What's the run? 3. What about this one? Is it just 3? So I just go up 3 and don't go anywhere else? I go 1 to the right. Why do I go 1 to the right? Because 3 is the same as 3 over 1. Okay? So that's something that you got to understand. Does that make sense? So if they give you like a whole number, or I should say an integer, because this could be negative as well. All right? So you got to make sure you understand that it's over 1. Make sense? All right. So now, where do we go? We go to that y-intercept, and what do? We rise 3, 1, 2, 3, and we run 1 right there. Let's do it a couple more times. 1, 2, 3, 1. Let's go this way. 1, 2, 3, 1 this way. 1, 2, 3, 1. You don't really have to put all. Oops, did I mess up? 1, 2, 3, 1. 1, 2. No, just looks. I don't know. Maybe it was just my eyes. Oh yeah, it's perfect. See how it lines up nice and straight? Just connect them. Again, don't just connect, just don't get a little stubby line right in here, right? Extend it through your graph. Just looks a lot better that way. And that's pretty important. Everybody got that? Yeah, pretty easy. All right, you ready to go on? Sure. Let's go on. We're going to, so we learned the slope-intercept form. We're going to learn another form, and they just call it the standard form. This is usually what they start with, but I don't know, for some reason, I decided to be a little different yesterday and start with the slope-intercept form. But this is called the standard form. This one, it kind of looks nice and pretty, right? But it's not, I wouldn't say it's not practical, but it's probably not quite as practical as the slope-intercept form. Slope-intercept form's really practical. You just look at it. And you're like, okay, I know where the y-intercept is. I know what the slope is just by looking at it, okay? Everybody with me on that? Yeah, we did a couple of those already today. We did a few yesterday. The standard form, just by looking at it, you can't really tell where it's going to cross the y-axis, where it's going to cross the x-axis. You can't really look at it and say that's the slope, all right? So it's a little bit different. But we are going to work with it, okay? There is a nice, easy way to work with it. So here's what it is. Everybody ready to write this down? It's ax, and make sure that a is capital, plus by equals c. So that's the standard form. Now, like I just said a second ago, you can't just look at it and say, oh, that's the slope, or that's the y-intercept. This capital B is different than the little b that we did for y-intercept, okay? It's not the same thing, all right? Now, there's got to be a couple things that are true. So A, B, and C have to be all integers. Talk about what an integer is in a second, if I could spell it right. Integers, integers. Yeah, A, B, and C. I'll write that right here. So A, B, and C have to all be integers. So what's an integer? Any number that's, it doesn't have to be positive. Any number that is not a fraction. Any number that's not a fraction is an integer, okay? No fractions, no decimals. So, -3, is that an integer? Yes, it's not a fraction, is it? Now, some people might say, well, I could put it over 1 and it's a fraction, but anything over 1 is just an integer, okay? Everybody with me on that? So, I don't know, back probably before you took Algebra 1, maybe in your middle school math class, you probably learned this. Do you remember seeing stuff like, oops, yeah. So 1, 2, 3, and then what's over here? -1, -2, -3. All these numbers right here. And again, in another math class, you probably did this. You put a ... What does that ... mean? Just keeps on going. Just repeats that pattern. And you can also repeat the pattern to the left. Everybody see that? So what would be next after -3? -4, then -5, -6, and so on, okay? There's no fractions in here. Everybody see that? There's no fractions. So these are all integers. So A, B, and C have to be all integers. So A can't be a fraction, B can't be a fraction, C can't be a fraction. Everybody good? Okay, now there's one other thing. A has to be positive. It's got to be a positive integer. All right? So the B can be a negative integer, the C can be negative. All right? Now, none of them can be fractions at any point. All right? But A always has to be what? Positive. All right, so keep that in mind. We'll get to that in a few minutes. We're not going to get to it right away, but just keep that in your notes, keep it in the back of your mind, because we are going to talk about it eventually. All right? Now, here's what we're going to do. Just going to give you a little background to this first. All right, so there's our x and y axis. Let's just put some random line that goes through there like this. Okay? So there's our line. I don't know any of the numbers, and at this point, I don't really care. All right? What I'm looking at are two things. One thing we've already talked about, and that's the y-intercept. Now, yesterday, we talked about another intercept, but we talked about it very, very briefly, didn't make a big deal about it. All right? But look at this line. It crosses both axes. Would you agree? It crosses the x-axis and it crosses the what? The y-axis. So this point right here, where it crosses the y-axis, is called the what? The y-intercept. So take a wild guess what that point is called. That's the x-intercept, because that's where it crosses the x-axis. You got that? Okay. Now, here's one thing. I don't know, it's a little tricky, maybe, maybe not. Now, I didn't put any numbers on here, right? I don't know how far. I don't know if it goes up 2, it goes up 3, it goes up 1. I don't know, all right? But I do know that it goes up and down, right? So the ordered pair for that point right there, in order to get there, how far over on the x-axis do we have to go to get to this? If I'm starting here at the origin and I want to get to here, how far on the x-axis do I have to go? What is it? It's kind of a trick question, a little bit. I got to go 3 on the x-axis. On the x-axis, how far do I go to get up here? 0. Very good. You got it. Okay. No, on the x-axis. That's what I said. I said it a couple times. Okay. So on the x-axis, how far do you have to go to get up to that point? Nowhere. You don't go anywhere on the x-axis, correct? So what's the x going to be? 0. And then how far up do we go? I don't know, however far it is, right? I don't know the number, but let's call it y, because we go up on the y-axis. Everybody see that? All right. So the y-intercept, the x is always going to be 0. Do you hear me? All right, that's a key to what we're going to do today. All right, so in order to get to the y-intercept, the x direction, the x is always going to be 0. Let's do the same thing over here with the x-intercept. Start at the origin. How far did we have to go over to get to that point right there? I don't know, x, correct? We just went over x. We just went over a certain amount. I don't know if it's 2, 3, 4. I didn't put any numbers in there. I'm not really sure how far over that is. But I do know it goes along the x-axis, so I put an x. Now, how far up and down on the y-axis do I have to go? I go 0. So I make y 0. Everybody see that? All right, I'm trying to go slow, trying to let you catch up. Now, here's what we're going to do. In order to find, let's make this white again. If you want to find the y-intercept, okay, I'll just put y-intercept right there. What is the x always going to be? It's going to be 0. So I'll show you how we're going to use this in a second, but let's just write this down. In order to find the y-intercept, what we're going to do is we are going to set x equal to 0. Everybody see that? All right, because anywhere on here, look, if I put a point right there, what's the ordered pair? It's 0 something, right? Whatever it is. Okay, we'll just call it y. Does that make sense? What? No. All right. Everybody got that? So, no, stay here. You're in my class. You stay in my class. So, very good. So, in order to find the x-intercept, what do? Set the y equal to 0. That's really, really important. Okay? So, keep that in mind. Put it in a box or something. I don't know. Something that you're going to remember. Because we're going to use this in order to graph something that's in standard form. All right? And we do it by finding the x-intercept and the y-intercept. So how do you find the x-intercept? You set the other one equal to 0. All right? So you set the y equal to 0. To find the y-intercept, you set the other one to 0. So what's the other one? X. Everybody got that? Put it in a box. Remember it. All right. So now we're actually going to use, I'll keep that right there so we can see it. We're actually going to use these intercepts to find or to graph this equation. But this equation is not in slope-intercept form now. All right? It's in a different form. Oops. So looking at this, what form is that equation written in? Right, what's the name of the form, though? Standard form. This is in standard form, okay? What is the A? Is the 2, right, because it's AX, right? Whatever's being multiplied with the X. What's the B, the capital B? It's not just 3, it's, no, it's negative 3. So the B is negative 3. What's the C? It's negative 6, okay? So that's in standard form. What we're going to do is we're going to graph this using x-intercepts and y-intercepts. So what I'm going to do, tell you what, before I get started, let me grab this, copy this. I'll put that right there, push it over a little bit. All right, there we go. So what I'm going to do is I'm going to graph this thing right here. And looking at it right now, you're like, I don't know. I mean, I don't even know what the y-intercept is. I don't know what the slope is. What in the world am I supposed to do? Well, you can use x-intercepts and y-intercepts to find it. Okay, so wherever the y-intercept is, I'll put a point. Wherever the x-intercept is, I'll put a point. Then I just connect them and I'm good to go. Then I've got it graphed. It's actually a nice little way to graph things. All right, so let's do it. Let's do the x-intercept first. Okay. So if I want to do the x-intercept, what do I do up here? I set what? I set y equal to 0. What does that mean? I'm taking this equation right here. You got it. So I'm going 2x. I'll tell you what, I'll put it in here just so you see what we did. But you are right, it would just be 2x minus 0. Everybody see that? So what we did, we set y equal to 0. So there's y, so I stuck a 0 in for it. Well, what's 2x minus 3 times 0? What's 3 times 0? Just 0. So what's 2x equals negative 6? Oops, what happened there? And then let's solve for x. What's x? Divided by 2. X is negative 3. So what's the x-intercept? It's at negative 3. So I come over here. I go on the x-axis, right, because this is the x-intercept. So it crosses the x-axis where? 1, 2, 3, right there. Okay? So it's a little different than what we did before, but that's what we did. We set y equal to 0, and then we solve for x. Now what do you think we're going to do? Find the what? Find the y-intercept. So how do we find the y-intercept? What do we set? Set x equal to 0. So let's put that in here. All right? So there's our equation right here. This is the equation we're using. So I go 2 times what? 0 minus 3y equals negative 6. Let's do the math. 2 times 0 is 0. So I've got negative 3y equals negative 6. How do I solve for y? Divide by negative 3. Okay, remember it's a negative, not just a 3. Y equals negative 6 over negative 3 is 2. So what do we do? I'm going to change colors here. Yeah, so that's the y-intercept. So we come up to the y-axis and we put a point right there. Now, what can we do with those 2 points? Okay, just connect them. You don't even have to find the slope to graph it. All right, you can just connect those 2 points, the x-intercept and the y-intercept. Stretch them out a little bit, make it look like a nice graph. Oops. All right, there we go. And there you go, there's your graph. Took a little extra work, didn't it? All right, so slope-intercept is really nice because you can just look at it and say, oh, that's the y-intercept. Boom, stick a point there. That's the slope. So you go from that point, you rise and you run. Everybody with me on that? All right, so the slope-intercept form is really, really nice, but this is pretty good too, all right, to find the x-intercept and the y-intercept. And making one of those things 0 makes it super easy, doesn't it? Because it just completely gets rid of it. When I made this 0, it completely gets rid of it, and I can just very easily solve for x. Same thing when I set x equal to 0. It just got rid of it, see right there? And then very easily you can solve for y. And then you just plot the 2 points, put the 2 points on the graph, connect the 2 points, and you're done. You've got your graph. We okay with that? All right, good. Let me just do this real quick. This is kind of, I'm being a little bit picky, but that's okay. What is the actual x-intercept? Like, what's the point? Let's do this in a different color. Like, what's that point right there? Right, it's negative 3, 0. So if I asked you not to graph it, but what if I said, find the x-intercept? How would you write your answer? You wouldn't just write x equals negative 3. How would you write your answer? You got it. That's exactly right. Okay, everybody see that? What's this point right here? 0, 2, good. Okay, 0, 2. So what if I asked you the question, what if I said, and I believe this is on the quiz or test, okay? I might not even ask you to graph it. I just say find the x-intercept and find the y-intercept, okay? And then your answer should look like a point, an ordered pair. And what is the y-intercept here? 0, 2, right, 0, 2. So this would be the x-intercept, this would be the y-intercept. All right, so I could ask you a couple things. I could give you this graph and ask you to graph it. So you find the x and y-intercept, put the 2 points, connect them, you got your graph. Or I could just ask you a question, not to graph it, but just find the x-intercept and find the y-intercept. So you go through the same process. Just give me the 2 points. You just don't have to graph them. We got it? All right. Well, I hope we got it. Let me see what else. All right. Let's do another thing. Now, I'm going to really test your algebra skills on this, okay? It's not much. We've actually done this before. We've actually done this, I think yesterday, or one of the days, I forget. We actually did something like this. Oops. Come on. There we go. All right, so we know how to graph that with using x-intercepts and y-intercepts. But what if I asked you to graph this using slope-intercept form? You're like, well, wait a minute, Mr. Hamrick. It's not in slope-intercept form. All right? How in the world do I graph it using slope-intercept form if it's not in that form? Make it into that form. Exactly right. Alani got it. All right, so let's make it into that form. So what is slope-intercept form? It's what? Y equals mx plus b. So what do we want to do to this then? I want to solve for what? I want to solve for y, right? I want to get y by itself. Okay, remember we did this yesterday? We did a little bit of this yesterday, okay? If I want to get y by itself, what's my first step? Subtract a 2x, that's right, okay? So if I subtract a 2x from this side, I got to subtract a 2x from this side. All right, so that cancels. What am I left with? Negative 3y. Now, let's think about what order we want to put this in. Do I want to go negative 6 minus 2x? No, because the x is before that number here, isn't it? All right, so let's put what? Let's write it as negative 2x minus 6. That's a better way to write it, all right? Because we got the x first here in our slope-intercept form. We got one more step to do. Let's do it. What do we do to get y by itself? Divide it by negative 3. I think we did this exact problem yesterday, didn't we? Something like it. It seems very familiar, okay? And then what do we do here? Divide that by negative 3. And what do we do here? Divide that by negative 3. So what happens to this? Cancels. Y equals negative over negative. What's that? Positive. And so how do I write that thing? 2 over 3, and then just put an x right next to it. And then what do we have here? Negative 6 over negative 3, which is positive what? 2. All right? So I could take, let's see. I'll tell you what, let's do this. Let's put this up here. I grab everything. Yeah. Copy. And let's put it underneath of there. And let's put it in another color because we got a couple graphs. Well, at least we got one graph on there already. Okay, so we make it, come on. There we go. Got it. All right, so what we're going to do is I want to look at the graph we already have there, and I want to look at that green. Let's see. If I was to graph it in green, what would I do? I'd put 2 on the y-axis, and that's the y-intercept, isn't it? Just like we said it was over there. So that should make sense to you. Would you agree? We found the y-intercept to be 2, and we solved for y over here, and the y-intercept is 2. So what is this? What is that 2/3? Let's rise over run. So look, let's do it. Let's rise how many? 2, 1, 2, and run what? 1, 2, 3. Right there. My graph was off just a little bit, but that's where it should land. So would you agree that the graph for this green one is the same exact graph as the one where we did the x and y intercept? Yeah, absolutely. It's the same thing, all right? But on a quiz or a test, I might say, graph it using x and y intercepts. So I got to see that you got the right intercepts. Or I might say, graph it using slope-intercept form. And what would you have to do? You got to put it in slope-intercept form. So you would have to go through this, get y by itself, and then you would graph it from here. Does that make sense? So look. Let's just do a regular graph. So like this is you on your own paper. Okay, let's say you didn't have any graph paper and you just draw your x and y axis, and then you put in some little marks here for the numbers. Try to keep them as evenly spaced as possible. Okay, it doesn't have to be perfect, but it should be pretty close. All right, let's just go to yellow on this. All right, so how would I graph it just from here? We already did it up there on the other one, but I want to do it like this. So you put it right here, right? And then go up 2 over 3. Well, I don't have 2 here, but let's put another one. So what do? Go up 2 and run 3. Put a dot right there. So this is how you would do it on your paper. Okay, if you didn't have graph paper, this is basically how you would do it. And there you go. That's your graph. Now technically, you should have arrows at the ends. If you don't put the arrows, I'm not going to mark it wrong, but you should put the arrows on there. And that's your graph, okay? That's how you would do that graph. So, I don't know, what would you like? What do you prefer? Do you prefer solving for y and then graphing the y-intercept and then the slope? Or do you prefer finding the x-intercept and the y-intercept, putting the 2 dots and connecting them? I don't know. I don't think either of them is any worse or better than the other one. Do you? Tell you the truth, if it was me, right? Now, of course, I have a little bit more experience than you guys have doing this stuff, all right? But if it was me and they just said to graph this and they didn't tell you how to do it, I'd probably do it this way, okay? I'd probably get y by itself and then do the y-intercept, do the slope, rise over run, and then you got your 2 points and then you connect them. But this is the same graph as this, exactly the same. Okay? I don't know. I'm just worried that not worried, but concerned that you've learned this stuff right here. Let's see. I think we've had enough, all right? I don't want to, there's more that I could do, but I think I want to take this in bite-sized pieces, you know what I mean? Because I just want you to make sure you know how to do this stuff. So we got a little bit more to do with this. So we'll probably have a, what? C? 3-5C tomorrow, all right? I know some of you aren't going to be here because you got football, but those that are here, we're going to do 3-5C. And if you're not here, what's your responsibility? Right, let's go to the YouTube channel and watch the video, all right? So make sure you go to it. It'll be on there. Watch it. Take notes on it. That's what you should do. Is anybody going to actually do that? Probably not. Right. But the thing is, you're not doing enough. Okay, you're not doing what you're supposed to do. If you don't watch this video, I was talking to a teacher the other day, like, man, these kids have it so good, especially in my class. I could have never even dreamed. When I was your age, hate to say that, sound like an old man. Well, I am an old man, so I can say this stuff now. So, when I was your age, we didn't even have the internet. Okay? Stop with the noise. We didn't even have the internet. All right? So, we didn't have any YouTube because there was no internet. There weren't even like really computers that we could use. It wasn't until I got in college where I saw my first computer. All right, I wasn't, it's kind of true, kind of not true. But anyway, I never saw students have their own computer. It was like one computer in the whole school, right? And my point is, you have such an advantage. You have such an incredible advantage with me putting this on YouTube, and some of you guys don't care and you're not using it. All right? And it's a shame because you have the world of information at your fingertips. You really do. You literally, and I don't say that a lot literally, but you literally have the world's information at your fingertips, okay, with your phone. You can find out any fact, any statistic, anything on your phone, all right? So we couldn't do that when I was I would have to take notes, or I'd have to talk to the teacher, or I'd have to talk to my dad. Luckily, my dad knew how to do a lot of math because he was a teacher as well. He was a science teacher, but he knew his math. Not everybody has that. But look, everybody in here, I think, has a phone and has access to YouTube. Everybody has that. So use it to your advantage, for goodness sakes. Let's use it. Okay? All right, enough of that. I just feel sometimes like I'm talking to that back wall, and I'm getting as much response from that back wall as I'm getting from students. Sometimes I feel that way. It doesn't mean that's true, but sometimes I feel that way. All right, enough of that. Again, I'm not even going to give you homework. I will give you homework tomorrow, though. Okay, so I'll put it on there tomorrow. All right.